Welcome to Networks Professionals.
Welcome to The Explainer. You know, if you've ever wondered how the absolute biggest organizations on the planet keep their massive, super complex networks running without a single hitch, well, you're in the right place. Today, we're demystifying enterprise networking by looking at its undisputed gold standard. We're talking about MPLS. Think of it as the ultimate network VIP lane. So get ready, because we're going to break down the fascinating mechanics that quite literally keep the modern corporate world spinning. Let's just dive right in.
So, here's the million-dollar question. How do giant enterprises guarantee their network never drops? It's a massive challenge, right? Especially when you consider that network downtime can cost companies, on average, a staggering $300,000 for a single hour of being offline. If you're relying on traditional IP routing over the public internet, you're basically hitting a huge bottleneck. Imagine traditional routing is like sending a letter through the postal service. At every single post office along the way, someone has to stop, read the entire destination address, the name, the street, the city, the zip code, figure out exactly where it goes next, and then send it on. In networking, that is incredibly slow. It's a compute-heavy process. Every router has to do a complex IP destination lookup for every single packet of data. And you know what that causes? Friction, delays. But enterprises just can't afford delays. They need a VIP fast lane. And that is exactly what we are exploring today.
All right, here's our roadmap for today's explainer. First, the network VIP lane. 2, how MPLS actually works. 3, core enterprise benefits. 4, real-world use cases. And 5, the cloud era shift.
Section 1, the network VIP lane.
So MPLS stands for Multiprotocol Label Switching. Basically, it's a highly reliable WAN, or wide area network, routing technique. And it pulls this off by directing data packets through private network paths using really short labels instead of those complex IP addresses we just talked about. Remember that postal service analogy? Well, if traditional IP routing is reading the entire address at every single stop, MPLS is kind of like slapping a pre-scanned giant barcode, just a single short shipping label right on the outside of the box. The routers don't need to read the whole address anymore. They just scan that short label and instantly know which chute to throw the box down. Boom, done. These short, fixed-length labels create the incredibly predictable, high-performance connections that modern businesses absolutely depend on.
Moving on to Section 2, how MPLS actually works.
Now this process is super clean and logical, and it breaks down into 3 simple steps. Step 1 is label assignment. When a data packet first enters the MPLS network, it hits what's called a label edge router, or LER. This router's entire job is just to assign that short, fixed-length label to the packet. Then we move right into Step 2, label switching. And honestly, this is where the magic happens. As the packet moves through the core of the network, the core label switching routers, the LSRs, simply read that label to figure out the next hop. That is it. They brilliantly avoid all those time-consuming, compute-heavy IP destination lookups. They just see the label, switch it, and send it on its way. Finally, Step 3 is the label switched path. Because of this whole label system, packets travel along predetermined paths, which we call an LSP. This guarantees highly consistent latency and incredibly reliable delivery simply because the route is already carved out in advance.
Section 3, core enterprise benefits.
Okay, let's talk superpowers. First up, we've got guaranteed QoS, or quality of service. You see, MPLS natively supports traffic prioritization. So this means your mission-critical apps, like a CEO's VoIP call or some massive company-wide video conference, automatically get the bandwidth they need over less urgent data, like say someone sending a quick email. It absolutely ensures real-time performance. Second is strict security, and this is huge. MPLS operates as a private, closed overlay. Because you're basically operating off the public internet, you're drastically slashing your exposure to cyber threats. It's a closed loop. Third, high availability. Service providers actually offer rigid SLAs, service level agreements. We're talking ironclad guarantees for uptime, minimal packet loss, and super low latency. And finally, it's protocol agnostic. Whether your payload is IPv4, IPv6, or Ethernet, MPLS can encapsulate it, making it just incredibly flexible for legacy systems and modern infrastructures alike.
All right, Section 4, real-world use cases.
So how does this actually look on the ground? Well, our first major use case is site-to-site connectivity. Imagine you've got a corporate headquarters in New York, a massive manufacturing plant in Ohio, and regional offices all across the globe. MPLS acts as the glue. It securely links all these totally separate physical locations into one seamless private network. The second massive use case is data center access. Think back to before the cloud took over literally everything. Enterprises kept all their critical tools, their ERP systems, their CRMs, their internal servers locked up in a central data center. MPLS provides the high-speed, utterly reliable access needed so that an employee working in a remote branch office feels like they're plugged directly into the server rack right at headquarters. It is all about rock-solid, centralized reliability.
Section 5. The Cloud Era Shift. Now, MPLS gives us undeniable reliability, no question, but it can be pretty expensive to scale. And as we just noted, it's deeply optimized for backhauling traffic to a central data center. But what happens when your enterprise starts relying on Microsoft 365, Salesforce, and a dozen other decentralized SaaS apps? Funneling all that cloud traffic back to a central hub just to send it out to the internet? That creates a huge bottleneck. So, enter SD-WAN, or Software-Defined WAN. SD-WAN gives us cost-effective edge routing. It uses standard broadband and is perfectly optimized for these decentralized cloud-first SaaS environments. It essentially lets your remote branches connect directly to the cloud without ever having to go back to headquarters. So modern IT leaders are facing a huge tension here. Do you pay top dollar for the rigid reliability of MPLS, or do you embrace the flexible cost-effectiveness of SD-WAN?
Well, here's the good news. The modern enterprise doesn't actually have to pick just one. The ultimate modern resolution is the hybrid WAN. A hybrid WAN pairs the guaranteed, ironclad performance of MPLS for your mission-critical, highly sensitive internal operations with the cost-effective, direct-to-cloud broadband connections that are managed by SD-WAN. It is literally the best of both worlds. You get to keep that VIP lane for the traffic that absolutely positively cannot drop, and you use the flexible software-defined paths to give your branch offices lightning-fast access to all their SaaS applications. Honestly, it's just an incredibly elegant architectural evolution.
So, as we wrap up today's explainer, I really want to turn this directly over to you with 3 quick diagnostic questions. First, what does your current network architecture actually look like? Are you running an all MPLS setup, or have you already started moving toward a hybrid model? Second, are your branch offices currently struggling with cloud and SaaS traffic latency just because they're still backhauling everything to a central data center? And finally, are you actively evaluating SD-WAN solutions to modernize your own infrastructure? Take a moment and really think about these, because how you answer them is absolutely going to dictate the future agility and security of your entire organization. Thank you so much for joining me today on The Explainer. Keep learning, keep questioning, and I'll catch you in the next one.
Thanks for watching.